Hi everyone, my name is Manvi and my student ID is 101412099. So today I will be explaining you the assignment 1 for Comp 3132. So basically I have imported the basic libraries which is NumPy and I have named it as NP, then Matplotlib which is as PLT, TensorFlow, import Keras, and then from TensorFlow Keras I have imported the models and the layers. So let's begin with all the questions. So basically, first question here means is like basically we have to the loading the fashion dataset from the keras, and the dataset contains the gray cycle images of like 10 types of clothing like t-shirts, trousers, shoes and stuff. So it is split into the training and the testing sets. So code will do basically this line. So basically we have downloaded the data, and then we check the shape of the images and the label in both training and testing using these the image shape. So basically it prints the dimension of the images. For example, it prints the image dimension like 6028 and then 28, like in these are like in pixels in grayscale, which is standard format for the fashion MNICT dataset. Similarly, we print the lengths of the train labels and the test labels, confirming the number of examples in the both sets. Then we also print first 10 from both the training and the testing datasets to get an idea from what labels look like. So basically these labels are integers from 0 to 9, where each numbers corresponds to a clothing item such as t-shirts, trousers, pullovers, etc. And then we are printing those like length of the train labels, then length train labels, and then print length of the test labels, and then we are printing those. Sorry. And then we are visualizing the image in like here. Basically what we are doing is we now dive into the visual content of the datasets, where we are looking at the image at index 5 in the training dataset. So basically we print out the raw data at the index 5. Here you can see the code for the same. So this one. So basically you can see that it is basically like it is showing the raw pixel data at the index 5, and then we plot the images. Then we plot the image using the Matplotlib to visualize what the image looks like. And then you can see here, and then the line, basically this line converts the pixel data into the image, and then we have used the binary color map to make the image look in black and white, and after that we display the image as like plt.show. And then what we are doing is, so basically here we are doing the like we are checking the label for the image at the index 5, which tells us that what an image represents. And then we have like similarly we check the image at the index 500 in the test set, so that it prints both the pixel data and visualizing the images. So we here plot the image, you can see, and it is again in the black and white. Then we are defining and training the model. We start by defining like the random model. So basically it's like my network models dot sequential. So basically we are using, so this model basically allows to stack the layers of the neural network sequentially. And then we are doing like basically the we are flattening the 28 into 28 pixel images into a 1D array of n 784 values. Basically this requires in a 1D input vector. And then I'm sorry, and then we are normalizing the images, like before feeding the images into the neural network we normalize the value and divided it by like 255. And then we are adding the hidden layers with 512 neurons. and then simultaneously adding the hidden layers with 128 neurons, and then adding the output layer with the 10 neurons, basically, which is softmax. And then what we are doing is like we are compiling the model. So we are using the Adam optimizer and the sparse categorizer the loss function. The sparse category loss entography is used because the labels are the integers rather than one hot encoded vectors here. And then we are training the model, so we fit the model into the training data using dot fit function method, like function. This model is trained for like 10 epochs, and meaning it will go through the entire training data set like 10 times. So here you can see it went through like 10 times here. And then we then switch a slightly different approach by using the categorical cross entropy and converting the labels into the one hot encoded vectors using the keras to the categorical function. And then we are evaluating the model using the test data, checking the accuracy for both training options. And then we are this will basically gives an accuracy of a model of a test data set of both training approaches. So here basically we can see that accuracy is like 0.866 with a loss of 0.5810. That's it for my video. Thank you.